So again, I'm Sam Charrington. I am the founder of TWIML and host of the TWIML AI podcast. And I'd like to welcome Louis. And Louis, please introduce yourself to the folks who have joined us.
Sure, thank you, Sam. Very excited to be here. My name is Louis Dorard. I think that maybe the best way to sort of introduce me is to make that connection with the machine learning conferences. I think that's how we got in touch with Sam. Actually, when I got up this morning, I had this great idea of like wearing this conference T-shirt, but I just realized that you can't see it because this is a virtual session. So that's the thing with getting used to doing events virtually rather than in person. But so I took this nice Pepys conference conference T-shirt that says "Eat, Sleep, Train, Deploy," and Pepys is another conference that's focused on machine learning applications, real-world applications of machine learning that I've been co-organizing for the last 6 years, I think, and that's how Sam and I met. So we started this conversation on how we could partner up with TWIML, and it's amazing to see how TWIML has grown into creating its own conference. I've also written about machine learning platforms, recently published a report on that. So that's, I guess, another shared interest with Sam. And I think that, as you said, Sam, the idea of this course is to show how to build machine learning systems that create value. So sort of, bringing together the business side, but also the technical side, what are the possibilities of machine learning? And this is something that actually has been the focus at Pepys. It's a conference focused on real world applications of machine learning, trying to bring everyone who's interested in that to the same place. And that can be technical managers or decision makers or leaders in general, domain experts, and as well as engineers, machine learning engineers, or that's something that didn't exist back in 2014. So data scientists, software engineers, trying to bring everyone to the same place. So that's been one of my areas of focus, connecting the technical side with the business side. And also another effort that I've made to sort of do this is this framework called the Machine Learning Canvas, which is something that I created while consulting to help also bring everyone from a given team, all the stakeholders, and also all the different people that are going to be collaborating on a machine learning project, bring everyone to bring everyone on the same page, essentially. I'll be talking a little bit about this machine learning canvas. As I briefly mentioned, so I've been doing some consulting. I'm actually an independent machine learning consultant. And I've consulted and taught at places like Amazon Web Services, Intel, what else? Some of the big companies also based in France, because that's where I am right now. I did my PhD in machine learning in London, so I still occasionally I teach at my university, which is University College London School of Management as well. So yeah, I've been working with very large organizations, I would say, but also like tiny startups or even solo entrepreneurs, trying to tell them what to do with machine learning to actually create something that's useful, create value for their clients, their customers, their users, or maybe creating value for your internal team. So that's been my focus since the last few years.
Awesome. So that is a bit about us. Now I'd like to share a poll so we can learn a bit about you while we're getting Louis' presentation up. So you should see that poll pop up. If you would take a second to share what is your machine learning experience level, and also what best describes your current professional situation. And Louis, I'm going to stop the share so you can get your share up.
Just give me 1 minute to submit the poll and I'll be ready. Okay. All set.
And do you all see that poll? Well, Louis, you just submitted it, so yes. I'm not seeing any results coming in. Those usually come in live, so that is a bit strange.
Can I see the results by any chance? I mean, I think that might be interesting to. So usually, in a normal conference, I would just, ask people to raise their hands and get a feeling of, who everyone is. Are people rather technical or more or less technical? I'm guessing that, most people here should be of the sort of, leader / innovator type. I think that's how we pitched this webinar, but it's always good to double check.
Yeah, we may need to ask people to raise their hands because Zoom is still telling me that 0 out of 27 have voted. Let's see if it changes its mind when I end the poll. It does not. I think you said you voted in the poll,
I
Louis?
did, yes. Yeah, I did.
So not sure why it's doing that, but how about this? I'll quickly share my screen again. And so you can see the questions here. If you all would just sound off in the chat, what's your level of ML experience and what best describes your current occupation or title or role. Let's see if that works any better than our Zoom chat here or Zoom poll. Cool. Thank you for doing this. We're getting some great responses here. So know the main concepts,
Yeah,
program
thanks.
manager, have deployed ML in production, deployed in production ML engineer, consultant, main concepts consultant / business, hands-on experience, data scientist, hands-on experience consulting. A lot more data scientists and ML engineers than I would have expected. Hopefully you will.
I'm not that surprised because, even though, so this is the second time that I'm doing this course, first time with Tumor though, but it's the second time, and the first time around also had quite a few engineers and data scientists. I think that, it's a general concern to understand, machine learning in production or get the sort of full picture of machine learning. And actually so there's another reason I put this shirt on. It's because of what it says. So again, it says eat, sleep, train, deploy. It doesn't stop at training models. Then you need to deploy them in production. But also, I think that what's implied with this eat, sleep, train sort of routine is that there's repetition, right? And that's something that people who are getting started or who are experimenting with machine learning, just building models, may not anticipate from the very beginning that you're going to keep collecting new data and building new models over time. So you really have to think about it as a live piece of software or a live system that keeps on doing these things. And the other thing that I think is interesting is like the eat and sleep. So you could think that this refers to like me as a person or whoever wears that t-shirt, but you could also think of it as the system ingesting data, and the sleep would refer to, I think that also another misconception that people can have when starting out with machine learning is that you're just going to collect data at one point in time and then build a machine learning model from that. Or you're going to get data, historical data, And quite often when you just, get historical data, you've got issues like data leakage, because what you're trying to do with machine learning is predict something that's going to happen in the future. So one example that I'm going to cover in my short presentation is predicting bank loan defaults. So yeah, you have to decide, like today, whether you want to give out the bank loan, whether you want to approve or reject. And then you only get to observe whether there was a payment delay or payment default at the end of the loan, right? So if it's a 2-year loan, then you have to wait for 2 years, right? So you have to sort of wait, sleep. That's kind of the same thing when you're programming computers. So you have to wait a little bit of time and then get the answer. If it's a 20-year loan, then you have to wait a lot of time until you get the answer. So I thought that's also something nice to mention.
Nice. I love that analogy.
Thanks.
Tell us a little bit about, let's get your slides up and maybe have you share a little
Let
bit
me do
about
that. I'm sharing my screen right now, using Keynote. Okay. Can everyone see that slide?
Yep.
Yeah. You should say how to turn machine learning into value, right?
Yeah, I think this is a great place to start because, from this perspective, it's fine if you're a machine learning engineer, if you're a data scientist. I kind of positioned the distinction early on as kind of technical versus, leadership and oversight. But I like the way you have it here. The focus is on value. You could be a machine learning engineer or data scientist and not really be focused on value and thinking end to end and understanding how the systems that you build deliver benefit to your organization. This happens a lot in both data scientists and traditional software engineering. Folks get kind of augured into their small pieces of the bigger puzzle and don't think about the end-to-end value proposition. So I love starting with this value point.
Cool. Yeah, I think it's important because, right after that, I'll be talking about costs. So I think it's better to introduce things with, speaking about value. So the different sort of ways to turn machine learning into value, I think that a lot of people are familiar with predictive marketing, predicting whether you're going to be interested in a given product or predicting that you might cancel your subscription to a service. And that's one way to sort of increase revenue for whoever is working in marketing. So I tend not to use too many examples from marketing. What I try to do sometimes is show up things that people might have heard less. So increasing productivity of customers and employees, I think that's also one good area. I think that the most simple thing that you can do to increase productivity would be I think that one of the oldest pieces of software that uses machine learning is probably spam filters. And then the other way around, you have priority filters. And that can be really useful, not just for emails, but imagine you're a community manager and you want to, there's a lot of noise in all the messages mentioning your brand, and you want to focus on what's really important. So it's nice if you can sort of filter out the noise and then bring to the top of your interface of the interface of your community management tool what is really important. So that's an idea, priority filtering and spam filtering, that you can use in many places. And originally spam detectors they've been around for quite a while, right? So conceptually there's not that much that's changed, right, conceptually. I talked about predicting the future, so that would be the case with you predicting whether there's going to be a default, a payment default. So super interesting for banks. They've been doing that for quite a while. Maybe now they're going to be using new machine learning algorithms or new sources of data. Other examples could be predictive maintenance. So predicting that a piece of equipment is going to fail within a certain amount of time. And everything that can be automated with machine learning is going to be saving time and money by automation. So the examples I have in mind are, for instance, document classification or just, extracting information from scanned documents, which would be done manually. Quality inspection also, that's something that you need to do manually, but machine learning can be used to automate things. And you might think that, it could be a case of replacing humans with machines, but I'm going to be talking about that soon in a couple of slides. Just a very quick recap for those who are not that familiar with machine learning, but I don't think that that's the case, or you never know. I mean, I saw that some of you were quite experienced. You never know. This is an example of real estate data where each line corresponds to an input that we're going to be using in our machine learning system. So that's a real estate property. Each column corresponds to an aspect of that property, a feature, we would say in machine learning parlance. And there's one property in particular that we're interested in. It's the price. We only get to observe the price once the transaction's been sold. So we need to wait for a little bit of time to collect that piece of information. And basically machine learning is using all the data where you know the price, the thing you're trying to predict, and then use that to build a model, apply that model to fill in the missing values in the price column. Right? That's a very simple way to think about it. Just filling in missing values in a given column of your data. Usually that would be in the last column. So that thing that we try and predict, that's the output. So input I, output O. So I'll be using those terms later on. Now I just want to, so the screen is black, that's normal. I'm just using that to sort of not distract you from thinking about, like, okay, let's think about what it would be to predict payment defaults, right? What would we have as rows and what would we have as columns? So we would want to have information about the bank loan, right? And that's probably, we probably also want to have information about the person who's applying for that loan. So each input, each row is going to correspond to a loan application. And the columns that you might have could be information about, again, the person applying for that loan, their age, their education, their income. So those sorts of things. Maybe you want to have some information about the loan itself. So that would be your columns. And then there's one column that's of interest, which is, is there a payment default or not? So you need to wait to observe whether there's a payment default or not. And then once you've waited for some time, you've collected some, what's called some training data, you can build a model. So that's the idea of building models from training data. It's a bunch of examples of inputs and associated outputs. So the real estate properties and the price at which they sold, or the loan application and whether it was a good loan or a bad loan. And then so you feed that in, you get what's called a predictive model, and you use that model to make predictions of what the output should be for a given input. You might be wondering, how do I build a machine learning model? It turns out that there's tools that make it super easy. So very often people think of hiring people who know about machine learning algorithms, hiring data scientists, but you probably don't need that when you're just starting out, when you want to create new value with machine learning. I'm not talking about improving an existing machine learning system and creating more value. I'm talking about creating new value on targeting a new use case. You don't want to worry too much about machine learning algorithms. Actually, you can get a lot done with what's called automated machine learning, AutoML. So this is taken from Wikipedia. AutoML was proposed as an AI-based solution to the ever-growing challenge of applying machine learning. So it's kind of AI used to build AI, right, in a sense. So what I want to say is that machine learning algorithms are not the bottleneck, right? So just use automated machine learning tools, and then you can create your first models. Okay, let's talk about sources of cost in machine learning, because that's also, I think, something that's not perfectly clear when you're starting out. It's going to be costly. So there's huge gains to get, but also there's quite a few areas that will cost you money. So compute costs, obviously, all the time that's spent creating models and delivering and creating predictions also. Development of the model, so the time that you spend, figuring out what's the right way to build a quality model that makes good predictions, but also the what's different with machine learning software compared to traditional software is that you need to keep an eye on it and update it frequently. Traditional software is just based on code, but machine learning software is based on code and data. So the data represents how the world is, and the world changes. So you need to always keep collecting data and then refresh your models with new data. If you don't do that, then the performance of your models in production could be decreasing and could end up, the models could end up being bad ones. So you need to keep an eye on that. So you need to do monitoring. So that's obviously time spent. So that's a cost. Another thing that might not be obvious at first is that when you are creating value with machine learning, it means that you're solving someone's problems. You're providing a solution to some of their problems, and that means you need to identify who the end user is and what is their workflow, because you're only going to get value if you change that person's workflow, but there's a cost associated to that. So sometimes it's not a big cost, but I was talking about quality inspection. So in the manufacturing industry, maybe there's a big cost associated to that. And then prediction errors. So this is specific to machine learning. Let me talk about that in a little bit more detail. Let me illustrate with still the bank loan example. Let's say that the average amount of your loan is $5,000, and let's make another assumption, which is that the profit for the bank is $500. This is completely made up. Actually, it's a student of mine that suggested that, so I just shamelessly stole this example. But what you can do, maybe not right now, but think about it later. What you can do is to think about what is the cost of predicting that the loan is a good one, that there won't be a payment default when actually it was a bad loan. So there was a payment default. What's the cost of that? There's another type of error. There's only two types of errors. The other type of error is predicting that it's a bad loan when actually it's a good loan. So I think that this is a missed opportunity for the bank, because if you're predicting that it's a bad loan, then you won't be profiting. So think about that, and actually what you can do is also think about the gains from correctly predicting that a good loan is a good loan and a bad loan is a bad loan. So what I'm trying to convey here is that you can put numerical values, you can associate numerical values to these errors, but also to correct predictions. And then if you put all of these values, so there's four cases, right? Two types of correct predictions and two types of errors. If you count, how many correct predictions and how many errors of one type and the other type, you've got numbers that you can put in one matrix. You've got a cost matrix or gain matrix. If you add that up, if you multiply and add that up, you can get a total gain and total cost. But that's just, in your extra time, something to think about. Okay, let me go back to how to turn machine learning into value. Nothing new here, but well, the value that you create needs to outweigh these costs, right? So it's, you should keep a close eye on that. Our example was, I think, a case of reducing costs by predicting the future, but also saving time, which means probably saving money with automation. But also I think that it also enables a new type of feature on your on the website of the bank, which is that you could get sort of a pre-approval of your application. If you just fill in a form, a prediction can be made instantly, and you could get sort of a pre-approval, something that wouldn't be possible if you need someone to actually review the application. And right, that brings me to that point about, do we want to replace humans? I think the idea is to enable new use cases. Same thing with spam detection. You don't want to have someone, look at all the emails and say whether it's spam or important. You want to have a machine do that. And the machine is going to be able to do things at a much bigger scale than what can be done by humans, or at a much smaller cost also. It would cost a lot of money to have like a personal assistant go through all your emails, right? And decide whether it's spam or not. So a machine is fast, then you can do that for, it costs less money, but also you can do those predictions for way more people. The other point is that the machine doesn't get tired. So if imagine that the human is doing a lot of repetitive work, quality inspection, maybe at some point you're tired and then you're not seeing that there's a defect on that thing that you're inspecting, on that manufactured piece of equipment that you're inspecting, then that's an issue. But what if the machine could sort of do a first analysis? If the machine is very confident that there's a defect or that there's no defect, then the decision is taken out automatically. But if the machine is not that confident, then you would ask a human. So humans would be able to focus on what really matters, what's more difficult for the machine. So you could have both working together. Right, and the other advantage I would say would be that using machine learning, you're able to take more information into account. And the example that I like here is diagnosing a disease. Of course, that's something that doctors are able to do, but the hope with machine learning and with data is that we can do a better job because we're using way more observations of what's happened in the past, way more observations than can fit in the human brain, right? Okay. So that was the sort of introduction on creating value from machine learning. If you've read the information about the course, there's a point of talking about machine learning systems, so creating value with machine learning systems, and you might be wondering, why are we talking of systems when usually people would be talking about models. The reason is that there are several components that you need to build in order to make that work in production. So it's not just a model that makes predictions on your laptop. You need to have a model building component to which you would send data, new data, fresher data periodically, and that would create new models. So you want to automate that and make that easy to create new models based on your data. You also want to collect data, right? You need a piece of software to collect that data, maybe to label that data, and also to prepare that. Right? I think that one example is that taking into account the monthly income of a person and the debt ratio to come up with another feature that would say the amount of debt that they have, or you would maybe combine different bits of information to create new information that might help the machine make predictions, or maybe you just want to fix things in your data, missing values or erroneous values that you need to fix. And then you need a component that evaluates your machine learning predictions, not just in sort of a lab environment, but also in production. As you get new data, new production inputs, you want to, as I said, you want to monitor the health of your machine learning system, the quality of the predictions. So you need to use that evaluation component in order to do this monitoring. Right? This has also to be deployed in production. It's not just evaluation for offline experimentation. And then you've got the end user application. So obviously, you need to connect the machine learning model to what the end user app is, the app that they're using to get that value that you're proposing. So that's a few. I think there's more. I've created this diagram to sort of give an overview of what these components are. I think that I have to go very briefly because otherwise we're going to be short on time. The idea is that I want to take another example, actually. I want to take another example of making predictions of how long it's going to take. So imagine that you're placing an order on Uber Eats. How long is it going to take to get that order delivered to your place? So the prediction would be a number of minutes until delivery. That's what would be called a regression problem, because you're trying to predict a number. And previously we were trying to predict a class, payment default or no payment default. So imagine you're trying to predict, how long it's going to take. That probably depends on the context, like, how busy the restaurant is, or let's just, keep at that, how busy the restaurant is. And the context could change very rapidly. It just takes a few people to make orders, to place orders to the same restaurant at the same time for that restaurant to go from quiet to super busy. And so you need to take this piece of information into account to make that prediction of delivery time. So this is a feature that you need to get from the production database. And the value of this feature can change quite rapidly. So quite often I think that this is something that people don't take into account when they think about how long is it going to take to make a prediction. It's not just about getting the prediction from the model, it's also about featureizing the input. So the input would be information about the order and also the context. You need to update that. So you need to create those features to compute those feature values. And that's why you need a specific component for that, which is the featureizer on the left-hand side. The front end would be maybe slightly changing the output of the predictions. So maybe instead of saying it's going to be 22 minutes with a certain degree of certainty, maybe this is going to get converted to you get your order in 15 to 20 minutes. So maybe you want to do some post-processing on the outputs of your machine learning model's prediction. The server is the piece of software that's in charge of serving predictions. So you're going to send your featureized input, you're going to get back a prediction, right? And then with the front end, you can post-process that. And then at the center of everything is this orchestrator that sort of orchestrates things, right? That's the piece of software that's in charge of getting the data from the database, maybe splitting that data into training data and test data, using the training data to build models, so using the model builder, and then applying what comes back from the model builder on the test set, getting predictions on the test set, and then using that, passing that to the evaluator to know whether the predictions are good or not. And so this is something that probably many of you are doing already, but if you would be deploying in production, you would also need to deploy this evaluator, because you want to be monitoring. Okay, so I'm not sure why there was a black screen here, but never mind. This is the full diagram. I don't really have time to explain it all, but yeah, I think that this is just to sort of show, and this is the colored version where what's in purple is components that need to be using machine learning models. All the rest actually is not specific to machine learning. So I thought that's
this might be a
interesting.
good time to break and ask if anyone has any questions that they might want to ask or toss into the chat. Any questions?
Actually, let me see if so I wasn't able to see the chat while I was presenting, but let me have a look. Okay.
If not, I'll let you know if we get any questions coming in. You also cover in this presentation and in the course the Canvas model that you've developed. Can you share a little bit about that?
Sure. And actually, I think that seeing the sort of complexity of machine learning systems, seeing all the components, um, I think that, you need to sort of have a way to structure your approach to machine learning. And that's what the canvas is here for. It also serves to connect the value proposition to a machine learning task. So connect machine learning's possibilities to what your end user cares about, or to your organization's objectives and key results. This is what the machine learning canvas does. And also when you fill it in, that gives you a lot of information that serves as specifications of your machine learning system. And right, this is just a quick quote to introduce the canvas. The full quote, I think, is: "The formulation of the problem is often more essential than its solution, which may be merely a matter of mathematical or experimental skill." And that's really the case for machine learning. It's an experimental discipline. So that's what the machine learning canvas helps you with, formulating your problem. Basically, it looks like this. It's just a bunch of questions, but they're arranged in a way that makes visual sense. At the very center, you've got the value proposition. So what are you trying to do? Who is it for? Who's the end user of your predictive system? What are the objectives? And then somehow you need to tie this to a machine learning task. So maybe this could be very easy. Maybe the value proposition is to spend less time in your email inbox, and the machine learning task is to predict if an email is important or not. So the input would be the email, the outputs would be a class, important versus non-important, and the type of problem is classification. Sometimes you'd start with a machine learning task. You would say, wouldn't it be cool if we could predict this? And then you need to connect that to a value proposition. So I've seen, both ways, either starting from value proposition or starting from machine learning task. And then the decisions box, which is on the left-hand side, sort of tells you how you're using the output of your machine learning model to provide that value that you propose at the beginning. Let's have a look at the next slide, I think, which should be showing the sort of structure of this document. The center is the goal, the what, why, who, and then you've got the how. So making predictions, but also in order to make predictions, you need to learn models from data. So how with data and learning from data. So everything that's in yellow is focused on that. And then the last bit is how well you're reaching your goal. So that's the live evaluation in production and monitoring of your model. You want to monitor the accuracy of predictions, but maybe also your bottom line. What is the impact on your bottom line? I think that I think we're getting very close to the end of this presentation. I might have a couple of other remarks to give, but let me just, did we get any questions in the meantime?
We do have a question coming in, and it's a good segue to talking about the class itself. You've presented so far a couple of interesting tools: the system diagram and the canvas. Let's kind of jump forward to the class outline and talk about the structure of the class and the
so I'll hand over to you, and
sure,
let's do that.
Let's see. Why do my Zoom windows always disappear?
Stop share. Okay.
There we go.
So let me answer this while you bring up the slides, Sam. There's 7 parts in the course, and one of them is specifically, it focuses more on the machine learning canvas. it's the part that's entitled Design a Machine Learning System that Creates Value. So if you have a look at that slide, yeah, there's 7 bullet points, and that would be part 5 of the course. But everything that comes before helps you understand what you need to put in that canvas, right? So everything that parts 1 to 4 will help you understand which things you need to think about and what information you need to put on that canvas. And then part 5, again, that helps you sort of filling in that machine learning canvas, that helps you figure out, what are the constraints that you might have, technical constraints or specifications that you might have if you want to deploy your models to production. And then also what you'd be thinking about with the machine learning canvas. So you'd be thinking about your end user, their workflow, how you're changing things to their workflow, and that makes things really real, right? And that also, I think, puts you in the right state of mind to think about, all right, can we trust these predictions, right? Like imagine, your end user actually relying on this to do their job. Can we trust that? And then when you're in that state of mind, you start thinking about, more tests that you should be doing to make sure that the model is good. You want to make sure that the average performance is good, but you also want to make sure that it's not doing anything stupid in certain cases. So this is what's explained in part 6, how you go from a baseline model to something that's, that could be deployed to production, a minimum viable model that you can trust, and then on to deploying things.
Got it. And so James's specific question is, what percentage of the class is focused on the Canvas versus technical topics? Maybe you can spend a second talking about the technical level that you're assuming and delivering in the class.
Sure. So I'm trying to, I wanted to make this like a practical course and to make it very hands-on. And at times, you'll have to do things, right, to get your hands dirty if you want to, follow and do the exercises and then actually apply this to a real use case. Of course, it's still possible to just look at the videos, watch the videos, and be like, looking over my shoulder, what I would be doing in that case. So I think that, even if you don't have a technical background, you would still understand what's going on, right? And actually, I've had people in the past who took that course who did not have a technical background, who'd be, specializing in user experience, or who would be project managers, not having any specific IT training or IT skills or programming skills. But there's, that being said, I think that there will be a little bit of code that you would see. I tried to use as much as possible to use no-code tools and graphical interfaces that still get you. You can still get a lot of stuff done with just pen and paper and with point and click tools. But sometimes, like for part 6, from baseline to minimum viable model you can trust, I did use a little bit of code to make a deeper analysis of the models. This is code that you don't need to change. Maybe if there's one thing that you need to change, it's the name of the data file or the name of a CSV file, and that's it. You just reuse the code as is. So you don't need like strong technical skills. You don't need programming skills. And the environments I'm providing, it's a cloud-based environment. I also have a sort of a local alternative if you don't want to use the cloud, but this makes it super easy to get up and running and just reuse those code templates. So not too technical, even though some bits will be technical because we'll be talking about some specifics of the machine learning systems that you want to build. So trying to bridge that gap again between the technical side and the business side. In terms of percentages, it's difficult to say, but let's just say that it's 1 out of 7 that's quite focused on the machine learning canvas, and then the rest is again, it contributes to knowing what you should write about in that canvas, but not specifically about the canvas. Everything that comes before it, and parts 6 and 7 are not specifically about the canvas.
Got it. You mentioned that there are pre-recorded videos that are accessible, and of course, one of the hallmarks of our approach to education and courses are study groups and a community learning model. Can you mention or speak to what you have planned for the study group sessions, which will be which will meet on Thursdays at this time?
Yeah. So the idea, I think, with the course itself is to save a lot of time, because you'll avoid some of the pitfalls, or you just know what really matters, and you'll be able to focus your attention on what really matters. You'll be able to better, if you're working with the team, you'll be able to lead that team more effectively. So that's a lot of time saved. And same thing, I think, goes with the same idea with the study groups. We've also called them the office hours to make it sound a little bit less academic. The idea is for you to be able to ask questions. Obviously, that's one thing that study groups are for. I think that's before speaking about what I would be doing. I think that it's also important to mention the benefits of just being together with others that are learning the same thing as you. You will learn things from them, and they'll probably learn things from you as well. So I think that just this is interesting, and knowing about sharing maybe some of the issues that others are having. Maybe you've had them in the past, and you can help others, or maybe or vice versa. But in terms of what I would bring, so obviously, spending time to answer questions, to explain in more details some of the sections that obviously I can't cover everything about machine learning in just I think it's 15 hours of video, and also providing feedback on so depending on how much time is available, but the idea is to provide feedback to everyone who's actually doing the applied work, who's applying that to their own cases. So giving practical feedback, or even if you're just doing the exercises, you're not sure yet what is the right machine learning use case for you. So I provide example use cases, I provide project ideas of things that would be nice to have, and that you can actually deploy in production. So not the sort of machine learning competition type of problems, something that's a little bit more real. So the idea would be also to use that time to help out if you run into practical issues.
Great. So let's take a second to have you review the various options and packages for the course. We mentioned the study group sessions. Can you speak to the details here?
Yeah, sure. So what you saw in the previous slide were 7 bullet points. There's going to be 7 sessions, and it would be at the same time on Thursdays every couple of weeks, every 2 weeks. The first session is, I forgot, what is the date? I think that was in the previous slide, but we didn't say that. I think it's on the slide, but yeah, October 1st, and then October 8th, because there's only 1 week in between, because the first part of the course is rather light. It's an introduction to get everyone started, and then every 2 weeks. So 7 sessions. you would also have access to the pre-recorded course, and that's I think that it's around 40 lessons. So that's about 20 minutes per lesson, 15 hours of videos in total. And so each part of the course, it would take 2 hours to review, and then maybe the same amount of time to do the exercises, maybe less, maybe more. That's difficult to evaluate for everyone, but at least it takes about 2 hours to watch the videos and prepare for the next, at least be up to speed for the next study group session or the next office hour session. I also provide, as I said, code templates. So these are low code templates. I think that's another thing nowadays. There's everyone speaking about no code tools, but also low code is of interest. And I've got also a bunch of other resources that I've made in the past. So I've put everything. I've got all my best content in this sort of bundle. And then there's this option with one-on-one coaching. Obviously, that's more time to spend discussing your specific issues. It's a 1 hour session with also a pre-discovery conversation via email, and also via email after that 1 hour session, follow-up and guidance is next steps.
Awesome. And for folks that want to access additional information or enroll, that link is the same one that you use to register for this webinar. That's swimlai.com/mlsystems. We are coming up on an hour, but we, are, here to answer any questions that you have. If you've got a question, feel free to unmute and ask it, or type it into the chat. While we're waiting for additional questions, you've mentioned that in previous versions of the course, you've had folks that have had data science titles and technical titles. Actually, I'm not sure if you said they took the course or they expressed interest in the course.
They took the course, yeah. And what's interesting, I think that's I'm thinking about the machine learning systems. So there's one guy who's a data scientist for this big company in this big media company, I think in Dubai. And so he told me that, he was quite familiar with most of the topics. And I could see, actually, I also have data on the sections of the course, that the videos that you've watched and those that you haven't watched. So yeah, always good to collect data everywhere. And I think that this will definitely help in the context of the office hours. But so I could see that he didn't look at everything, but what he got out of it was understanding the system side of things. So his training was in machine learning algorithms, or maybe also he'd know about how to pre-process data. But I think that all the aspects, and also I remember that he had some additional questions on everything that's linked to deploying to production. That was something that I think was of value to him. Actually, there's another person who's not a data scientist, but a researcher at, I think it's Adelaide University in Australia. And he also, is a professor, teaches machine learning, but, trying to spin out and do some consulting. And, I think he needed a way to structure his approach to machine learning. So I think that what he took away also, in addition to the systems aspect that that was of interest to him, was the framework, the machine learning canvas framework that helps approach clients.
So if you're an example of that, that may be common, maybe a data scientist who wants to better understand how to engage with their counterparts on the business side to, help them, structure projects and objectives for projects and that kind of thing. We've got a question in from
Yeah.
Nick asking, how closely does the deployment and ML ops section map to the technologies that we hear about today, like
Yeah.
Kubeflow and pipeline, Selden, and that kind of thing?
Yeah. So I tried to, keep things simple and not mention those frameworks, because I think that the first step, when again, this is in the context of creating new value, uh, targeting a new machine learning use case, and when you're just starting out, I think that it's best if you don't use too many frameworks. I'm thinking of this great book. I forgot the name. I think it's something like Machine Learning Applications. It's an O'Reilly book, also by a French guy. There's a lot of French guys in machine learning. But what he does is he explains pipelines, but not using any specific pipeline technology, just using regular Python code. And I think that, this also, when I read that book, it made it easier to understand, what he was doing, because you don't need to know any other framework, just regular Python. And same thing with Kubeflow. So using Kubernetes is, I wouldn't recommend using Kubernetes at first, because Kubernetes solves a scale issue. So first of all, you need to confirm that there is a scale issue. In many cases, there isn't. Or maybe there might be a scale issue in terms of scale. Could be scale issues could be relating to the training data you've got, or the number of predictions you need to have. Maybe there's no scale issue for making predictions, but you need to train your models on lots of different machines, and you're using Kubernetes for that. I think that it's best to make things simple. Also, when people ask me about doing machine learning with big data, I say don't do it at first. Just make the data small. Just take a random extract from the data and do like a prototype, or just build a baseline model first, and then analyze the performance of that baseline model, see if it creates enough value that you can just deploy to production. And in certain cases, something very simple is better than nothing, right? So yeah, this is just to sort of explain that I'm not covering these things, although I do cover them in one of my ebooks. So it says that what's included, you get exclusive resources. It says machine learning project checklists, model builder workflow, etc., and copies of my ebooks. There's one on machine learning platforms where I cover Selden, or I mention Selden at least. I'm not sure if I mentioned Kubeflow. MLOps is just, so I'm not going too deep in MLOps, but I think that what I want to convey is the deployment aspect, the thing that the fact that you want to be able to continuously deploy new models, update your models in production, and also that you need to monitor what's going on, but not going too much into the technical frameworks that exist.
Got it. Got it. Awesome. What other questions do you have? There's still a few folks with us. Feel free to just unmute and chime in, or unmute and I can call on you if you want that signaling. That is fine as well. But barring any additional questions, thank you all for hanging in with us. Thank you, Louis, for taking the time to both review the course, but also offer this to the folks in our community. I think in order for organizations to fully unlock what machine learning has to offer, we need all of the technical skills that we talk about all the time, but we also need leaders that are knowledgeable enough about the technical skills and kind of the broad frameworks that they can help guide the efforts of the practitioners to extract value. And I'm super excited that we're able to offer something to that community here.
Yeah, thanks everyone for the great feedback. It's cool to see that you enjoy the presentation. It's great to see that some of you are already signing up. And yeah, I'm really looking forward to that first session. So on October 1st, yes.
Awesome.